Welcome to another episode of Terry's Notes. So I've been getting numerous requests for me to do past paper questions. Now the thing is, there are a finite number of questions that CSEC can bring, alright? And me doing past papers, yes, will help in certain things. But at the same time, you all need to make sure you know your core chemistry content itself. So you need to understand your topics very well, because really and truly they can bring anything in the examination. Alright, so I'm going to do basically some quick revision, right? For those of you who don't have the time to go through all the videos because you just discovered the channel. Also, I would like to ask that you all fill out, I put a link on the page so that you all can fill out a form. This is to help you guys much better. And also I'm trying to create an emailing list, basically, right? So if I have new information, I can easily email it to everybody, right? So since I'm providing all this information to you all for free, I just have one favor. It will take you only about 5 minutes to complete that short questionnaire that I have on the channel. Okay, so let me just start, because I'm going to try to move through this as quickly as I can. So the first thing I'm going to look at is chemical energetics, right? So you need to understand the difference between an exothermic reaction and an endothermic reaction. So you have exothermic reaction and endothermic reaction. Right? Now, what you need to remember is, in an exothermic reaction, in an examination question, they might say you mix two chemicals or you mix a salt and water and there's something that happens, a temperature change occurs. So in the case of an exothermic reaction, let's say I have a test tube here with some liquid, whatever it is, and we come and we add something to this liquid here, right? And we notice that the temperature of the liquid rises. Temperature, it increases, right? Which means that heat, energy, is being given off to the surroundings, right? This type of reaction is exothermic because energy is being released to the surroundings, right? In the case of an endothermic reaction, what is happening is that, let's say I have a liquid again, some substance. So let's assume it's a liquid. And I come and I added something to the liquid. And what happens is that let's say you're holding the test tube, right? And the test tube begins to feel cold. We know that energy is being absorbed from the surroundings, right? In which case the temperature decreases. So the temperature falls. That's why it feels cold. So therefore it's an endothermic reaction, right? So what you need to remember is, when there's a temperature change, if the temperature increases, it's an exothermic reaction. And if the temperature decreases, it's an endothermic reaction, right? And you need to, if you have to explain what it is, what is happening to energy. In the case of exothermic, energy is being released to the environment. In the case of an endothermic reaction, energy is being absorbed from the environment. What you also need to be able to do is to draw what we call an energy profile diagram. So let's do one for an exothermic reaction first. So in this case, we have energy, right? Or in some books you'll see enthalpy. It's the same thing. Now this is where students get confused. Hold on one second. What's happening here? Okay, so here's the common mistake that students make. When they go to draw an energy profile diagram, they put energy on the vertical axis and they come and they put time here, right? CXC says this every time they ask a question like this, they put time, right? It is incorrect for us to put time. What you have to put is, hold on, let me just get rid of that time here. Yeah, what you're supposed to put is reaction pathway. Make sure and remember that. Okay, so it's energy against reaction pathway, not energy against time. Now it's an exothermic reaction here, which means energy is being released. So what you do, you draw first line here, right? And this represents your reactants. So this line would be the energy of your reactants, right? Then it's going to go up like this. Then we're going to come down, and this will be the energy of the products, right? So this is the general shape of the graph, but you also need to label certain things on the graph. So let's label the first thing. The difference between the reactants and your highest point on your graph, which is from here to here, that is called your activation energy, written as EA. So this is the activation energy, right? Now the difference between the reactants, so that's, draw a dotted line here, this distance here, right, is what we call delta H. It's a triangle, delta H, and delta H is what we call the enthalpy change. Enthalpy change, right? So if you have to draw an energy profile diagram for an exothermic reaction, this is what you have to do. You need to label this as energy, label this as reaction pathway, do not use time. I'm going to repeat it again. You draw the general shape, make sure that the products are lower, the energy of the products are lower than the reactants, because energy is being released. All right, now let's draw an energy profile diagram for an endothermic reaction. So in the case of an endothermic reaction, so we're going to have energy. We are going to have reaction pathway, and in this case energy is being absorbed from the surroundings, so we're going to draw our reactants here. So this is reactants, right, and energy is being absorbed, so the energy of our products is going to be greater than the energy of our reactants. So this is products. Right, now you need to label your activation energy. Activation energy is always the difference between the reactants and the highest point in your graph. So this here is your activation energy, which is EA, right? And the difference between the reactants and products is what we call delta H, or the enthalpy change. Now, in the case of an exothermic reaction, you notice that the energy of the reactants is greater than the products. So the this is the energy of the reactants is greater than the energy of the products. For an endothermic reaction, just by looking at the graph, we can say that the energy of the products is greater than the energy of the reactants, right? So make sure you understand the difference between an exothermic reaction and an endothermic reaction. Also, you'll have to give a definition for activation energy. Activation energy is the minimum amount of energy required to start a reaction, right? So think of the activation energy as the energy barrier, right? So it is the energy you need to supply to the reactants in order for the reaction to start taking place, right? Now, one more thing I need to show you here. Now, delta H is equal to the energy of the products minus the energy of the reactants. So in the case of an exothermic reaction, the energy of the products is less than the energy of the reactants. So therefore, if we take this value here, this energy value here, and we subtract this energy value here, obviously for an exothermic reaction, delta H will be negative, right? In the case of an endothermic reaction, delta H, we just said, is the energy of the products minus reactants. Now if we look at this here, the energy of the products is this here, and this is the energy of the reactants. So if we take products and we subtract reactants, you are going to get a positive value. So therefore, the enthalpy change for an exothermic reaction is negative, and the enthalpy change for an endothermic reaction is positive. Okay, let's move on. All right, something else you all need to know that they could ask in a question like this. They could ask you certain definitions, right? So the first one that you need to know is the heat of neutralization, right? Now, whenever you are given definitions, you need to be very, very precise. You cannot leave out anything. So the heat of neutralization is the energy change which occurs when 1 mole of water is formed during the neutralization reaction between an acid and an alkali. All right. Now there are certain key things that you need to mention here. So we need to say it's an energy change, right? And is the energy change that occurs when 1 mole of water is produced. That is very important. You have to say 1 mole of water is produced during the neutralization between an acid and an alkali, right? So you can check your book for a definition, or you could check the video on enthalpy that was done before. The next one that you need to know is heat of combustion, right? So the heat of combustion is a heat change that occurs when 1 mole of a substance in its normal state is completely burnt in oxygen, right? So again, you need to be very precise with your definitions. Okay, so that is heat of combustion. You also need to know a definition for heat of solution. So the heat of solution is the energy change which occurs when 1 mole of a solute dissolves in such a volume of solvent that no further dilution takes place, right? So again, just take your textbook or go back to the videos that I did before. Make sure you know these 3 definitions: heat of neutralization, heat of combustion, and heat of solution, right? Usually when they ask a question on energetics, they might ask you to draw an energy profile diagram. They might ask you what is meant by activation energy, what is meant by enthalpy change, and they might ask you a definition also, which could be neutralization, combustion, or solution. Make sure you know how to do that. Also, you need to know, this question may come with a calculation, in which case you need to know that the energy released in a reaction is equal to M multiplied by C multiplied by delta T, right? So usually if we have a mixture of something here and we have an energy and temperature change occurring, the energy released would be the mass of the solution, right? Now usually they give you these things in volume. So let's say they say 50 cm cube, right? The assumption is that 1 cm cube is equal to 1 gram. So 50 cm cube, we'll have to take that as 50 grams, right? And they may also give you what is, you need to know the specific heat capacity, right, of the solution. And usually they give us that in question, right? And also we need to know what is delta T, which is really the temperature change, right? So in the question, they will give you all of this information. This part of the question is usually pretty easy to work out, but when you have to work out for 1 mole of something, This is where students get very confused, right? So the question could ask you to find heat of neutralization, combustion, solution, but we always deal in 1 mole, right? So I suggest that you go back to the video on energy changes to look at the examples I gave on how to do the calculations. All right. So let me talk about something else now. Let's talk about an important topic here, which is rates of reaction. Right? So when we're talking rates of reaction, we are talking about how fast the reaction is taking place. Okay, so the first thing you need to know, you need to be able to give a definition for rate of a reaction, right? So here are the common mistakes that students make. When asked to say what the rate of a reaction is, some people put it's the time taken for reaction to complete. That is incorrect, okay? Now, the rate of a reaction is the, let me put it in a formula for you all to see it here. So the rate of a reaction, rate, is equal to change in concentration of the reactant or product over time taken for that change to take place. Time taken, right? So this is, if you cannot remember the definition for a rate of reaction, you can simply write this equation down and you will get the marks, right? So you can say it's the rate of change of the concentration of the reactant or product. Sorry about the handwriting. With time, right? So anyone, and you will get the marks. So that is what is meant by the term rate of reaction. What you need to know as well are the factors that affect the rate of a reaction, right? So the factors that affect rate of reaction are: 1, concentration, right? Now let's talk about concentration one time. So they may ask you for the factors, state the factors that affect the rate of reaction. So you need to give the list of factors and you need to explain why that factor increases the rate of a reaction. So what you need to know in the case of concentration is that when you increase the concentration of the reactants, now some people might be confused as to what are reactants and products. Let's say we have 2 things reacting here, A and B, and it's given us C. A and B are the reactants and C is a product, right? So C is a product and A and B are the reactants. Make sure you understand that, reactants. Right, so what I'm saying is that if we increase concentration, the rate of a reaction increases, usually increases, right? And why does that happen? So concentration. So if we increase concentration, rate increases. Right? Why does that happen? We usually use the collision theory to explain this, right? Now, if you have a container here and we have lots of particles of A and B, right? In order for them to react, they need to collide with each other, right? So when we increase the concentration, we are actually increasing the number of particles per unit volume, right? So if we increase the number of particles per unit volume, we are increasing the frequency at which we have collisions. And because we have an increasing frequency of the collisions, the rate of reaction increases, right? This is explained in one of my earlier videos. So basically you need to know that when we increase the concentration of the reactants, the rate of reaction increases. Why does it increase? You have to be able to explain this. When we increase the concentration, we are increasing the number of particles per unit volume, and therefore the frequency of the collision increases, right? And that is why the rate increases. So another factor that affects the rate of a reaction is pressure. Pressure. And this applies to gases. So this applies to gases. And if we increase pressure, increase P, the rate increases, right? Why? The explanation is very similar to increase in concentration, because when we increase the pressure, we are actually decreasing the volume. The particles, they move closer together, and therefore they collide more frequently, and that is why the rate increases. Okay, so this only applies to gases. If we have solids, pressure is not a big issue. It doesn't really affect the rate. The third thing is temperature. Most of you should be familiar with this. So in the case of temperature, if we increase the temperature, the rate increases, right? So how do we explain this? When we increase temperature, what we are doing is increasing the kinetic energy of the particles inside the reaction mixture, right? If we are increasing the kinetic energy, it means they are moving faster. If they are moving faster, there is the likelihood that they will collide more frequently, and they collide with more energy, and therefore you have sufficient energy in order to break the bonds in the reactants. So let me see another way to explain this. So start off by thinking like this: you increase the temperature, the kinetic energy of the particles increase. Therefore, the particles are going to collide more frequently. What you also may need to mention is that there are more particles having an energy that is greater than the activation energy, right? So remember, activation energy is the energy barrier, right? If the energy of your particles are less than the activation energy, it means that the reaction is not going to take place. Okay, so that is it for temperature. Another factor that affects the rate of a reaction is particle size. Particle size, or what we say, surface area, right? So if we increase the surface area, S, the rate will increase, right? Now, how do we explain this? So let's say we have lumps of marble chips, and we were to crush the lumps of marble chips. What has happened is that we are actually increasing the surface area. So therefore, because you're increasing the surface area, there is more areas or more regions in which collisions can take place now. Okay, so usually when they ask particle size, they usually give a question relating to calcium carbonate. So they might give you one with marble chips, and then they'll give you one with powdered calcium carbonate. When we use powdered calcium carbonate, the reaction will be faster, right? And it's because we have a greater surface area. So we have more surface exposed for collisions. Now the thing is, there is a disadvantage of having finely divided solids, because they tend to catch fire very easily, right? So for example, in flour mills, flour where we make bread and roti and those kinds of things, because of the fine powder, there's a chance that the flour could actually explode on you, right? Because of such a high surface area. Another thing that affects the rate of a reaction is a catalyst. Right? So when we put a catalyst, the rate tends to increase. Right? Now, sorry about that. Let me show you why. what the catalyst does, it provides an alternative pathway for the reaction to occur, right? And usually one that has a lower activation energy. Now, I just gave you some energy profile diagrams previously, right? Now, this is a question that you could see in your multiple choice exam. So we have energy, and we know this is not time, this is reaction pathway. So let's say we have something like this, right? This is an energy profile diagram. So we have, this is reactants here, this is products. So this is our activation energy here. Now when we add a catalyst to our reaction mixture, what happens is that the activation energy is lowered, right? So instead of the activation energy being this long line here, what we've done is made it shorter. So when you add a catalyst, what is happening is that the activation energy becomes lower. But notice how I draw this dotted line. I started at the same point where the reaction, we started here, right? And we must end up here, right? I've seen questions where they draw this dashed line in various positions. You need to remember it must start at the reactant and it must end at the product, right? So those are 5 factors that affect the rate of a reaction. Another factor could be light as well, but you just need to remember 5 and you should be okay. What you need to know as well is, let me show you something. You need to show, let's say we have a reaction A plus B and it's producing C, right? And we are monitoring the amount of C being produced. Now usually when we have a product or we have something written in square brackets, that represents concentration, okay? So in the case of C, the amount of C or the concentration of C with time will look something like this, right? You need to be able to draw what we call a rate curve. So we are looking at the product here. Remember, C is your product, right? So you need to be able to sketch a graph, and you also need to be able to explain the graph. So this is our origin here. Initially, when you now mix A and B, the rate A and B are at the highest concentration. Therefore, the rate at the start at t equals 0, this will be the greatest rate. Now just remember that the rate of a reaction is related to the slope or gradient, right? So if we remember our maths here, the slope is really the gradient of this line here, and when we reach this horizontal level here, the slope is 0, right? So therefore the rate, when you see a horizontal line here, the rate is 0. So therefore the rate starts at a maximum value here, and the slope is decreasing, and then eventually the rate becomes 0, right? So here, this part here, the rate is equal to 0. At this part here, our rate is a maximum, and in this region here, the rate is decreasing, right? So make sure you know the 3 sections of this graph here, right? So the maximum is really at the beginning, then it starts to get less steep in this region here, so therefore the rate is decreasing, and eventually we have a horizontal line, therefore the rate is 0. So the rate is a maximum because initially when you mix everything, the concentration of A and B are at their highest, and as fast as we use up the A and B, the concentration of A and B will start decreasing, so therefore the rate is going to start to decrease. Eventually we use up all of A and B, and therefore the rate becomes 0, right? So this is a rate curve. Now we can also have a rate curve like this. Let's say we were looking at the concentration of A. What happens to the concentration of A? right? So we have concentration of A against time. And what is happening is that concentration of A will continue to decrease, right? Until eventually A is used up. So again, we need to know that rate is related to the slope of your rate curve. So at the start, this is the steepest point here. So therefore, at this point, your rate is a maximum. In this region here, the rate is decreasing, and eventually the rate becomes 0, right? And the same explanation holds. At time t equals 0, the concentration of A is at its maximum, therefore the rate is going to be highest in this region here. As fast as we use up A, the concentration of A is decreasing, therefore the rate is going to decrease. And then eventually when we use up all of A, the rate is going to be 0, right? A typical examination question they can ask you here, if they are mixing two substances, let's say calcium carbonate and let's say an acid, they're going to ask you to draw a diagram of how you will collect the gas, right? So let's say you're going to have your marble chips inside here. Then you're going to have a tube. Make sure you put something to prevent the gas from escaping. And then the tube is going to go to a syringe. Right, so you might see something like this. Right, typical examination question. Sketch a graph to show how you collect the gas. Right. So that is it for rates. You need to be able to explain your graphs. Make sure you know your definitions. All right.